Binary data are not human readable unless you're a CPU. In this demo, I will show you how to decode the IP header and extract some useful information such as the protocol type, source IP address, and destination IP address. Do you remember your basic networking course? Now it's the right time to start using it. This table is going to map the binary code that we just saw in the previous demo to something we can understand as human. We will use the Python ctypes module to extract all these information. Let's start testing the program so you would understand how it works. Here at the terminal window, begin as usual with the Python keyword followed by the program name and press enter. I will use my browser to generate some HTTP traffic. Now this is something useful. I can see the packets flowing in and out from my network interface card. It's much better than reading binary data, right? It's a time to see the source code for this sniffer. At the top, we're using the socket library for TCP/IP. Then we're using the struct library and the ctypes library for extracting the IP header information, which we are going to see in a few moments. As usual, we start here by calling the main function. In the main method, we call the start sniffing function. I know someone out there is wondering why I'm putting one line of code in the main function. I could have called the start sniffing function directly from down below, right? Good question. And the answer is I wanted to show you a code that is readable. This is what we call clean code. So if I look at my program 6 months from now, I will still understand clearly my programming style pattern. For now, let's jump into the start sniffing function. In the first line, I'm instantiating the TCP sniffer object. If we take a quick look at this method, this is typically the same code that we saw in the first demo. Pay attention here at the first line that I'm specifying that my sniffer will listen to TCP packets. After that, bind it to localhost, then include the IP header, finally return back the object. If this is unfamiliar to you, please go back to the previous demo and watch it before proceeding further. Going back to the sniffing function, in the second line, we print a message to the user that we are about to start receiving packets. After that, we start listening indefinitely by using the while true loop. And guess what is after that line? Yes, you're right. We start receiving binary packets. Next, we take these binary data and extract the IP header. Before I show you the IP header class, I want you to see the variables that you are going to need from this class. In the next line, I'm using the protocol name to make sure it's TCP. After that, I'm printing the protocol name, the source and destination IP addresses. Let's take a peek at the IP header class. Do you remember our IP table in the slide? This is how it is mapped by Python using the ctypes library. The new method of this class takes the binary data and forms the structure from it using the from buffer copy function. It's important to know that classes always call the new function first, then comes the init function. When we start with the init function, the IP header is already mapped. In the first two lines of this method, we extract the source and destination IP addresses. Remember that this is binary data. That's why we're using the inet underscore NTOA to convert the 32-bit IPv4 into a human-readable IP address. Then we try to get the protocol name such as TCP, UDP, or ICMP. In this example, I showed you a TCP sniffer. I leave the exercise for you to extend it further with UDP and ICMP. If you really understood everything until now, this should be a piece of cake for you.